an invalid solution file, must the program just ignore it? Or must you actually write an error message? You must write an error message, right? So in this case where I gave the input incorrect solution file, you must write out a message that says not the solution. Okay. The idea in the solution file then is you have a number of blocks, you have their positions there. My example solution just had one block, but the movements of all the blocks must be specified in the solution file in order. Yes, in the correct order. So you would read the solution file, you would check if it's all valid, no overlapping blocks or anything. And then you should start executing the solution. If the red block reaches the right-hand side through a set of valid moves, then it's a solution. Okay? Okay. Right. Okay, so you'll notice that next week, yay, for South Africa, we have a public holiday again. I think we almost have the most public holidays in the whole world. And then every now and again, there's another one just for free, but okay. Next Wednesday is a public holiday so that you can go and vote, right? Which means we only have 2 lectures next week. So we're finishing section 3.2 today. Monday, we run through the first part of 3.3, and then next Friday is the last part of 3.3, second last. And then last Monday that I see you, which is the 8th. We finished 3.3, the Wednesday is revision, the Thursday is the test, okay? Remember, you have to hand in your project on Wednesday. Okay, so you either have to be finished studying for the test by Wednesday, or your project must be finished beforehand, because you have 2 deadlines right on top of each other. Okay, so don't leave everything for the weekend. Okay, so this is the last example on object-oriented programming. I'm a scientist, not a BCom person. No, I'm just saying where my interests lie, right? So in computer science, I don't particularly like databases. I rather like automata theory or things like that, algorithms and so on. But it is true that most computer science applications are in the commercial world, right? Incidentally, what does the acronym IBM stand for? You know, that blue company, that big company that bought the first PC. International Business Machines. That's what a computer is. It's a business machine. Okay? So you need to have a solid foundation on commercial applications. Okay? Even if it's not exciting and it doesn't draw nice animations and chase Pokemon or whatever. Okay? All right. This is where the money is. So we have this fictitious problem of a stockbroker. Yes, somebody who sells shares. And this guy has, or girl, as it may be, has a lot of clients. And for each client, they want to know which shares does that client have, how many of each, what is their worth, yes? So information about the client. So now you need to write the Java for that. Okay? And basically, the class that you're writing is for a given individual client, you want to keep an account with all the data. So we write a class stock account. We have a constructor stock account, of course, which creates a new account. So whenever the stockbroker wants to add a client, and they want to do that because they get a hell of a lot of commissions, the stockbroker can simply write a test client that creates a new stock account. So one stock account keeps the information about one client. One client can have many shares at many different prices and so on. Okay? Right. So you want to know in total how much is your client worth. If your client is me, for example, you don't answer the phone because I don't have many shares, so it's not worth your time to spend, it's not worth the money to spend time on me. And being an academic, the probability that I will add to my 300 shares is very low. Okay. So now, if you buy on behalf of a client, you add their shares to the account. If the client sells, you have to subtract the shares. And then you can save this to an output stream. And you can print a report which you can send to your client. So it's very simplistic, not totally real life, but it illustrates the object orientation. Okay. Normally, what you would have in real life is instead of the reading and the writing, you would have a database. And you would get your information from the database, okay? Instead of from, well, this code will also work with the database because I simply have a stream in. So if in can handle databases, then I'm cool. Yeah. Right. So how do we do this? Firstly, we have to know what the input and output would look like, okay? So this is what I like about having this lecture here, because you're also worried about input and output at the moment for your project, okay? So the suggested format over here is I get a name for a client. So that is what I'm going to into my object. I get the name of the client, and now I forget what it all says. That is the value, right? Account holder's name. Then the balance. How rich is Alan Turing? Who was Alan Turing? Come again? The inventor of the computer. Yes. Right. Have you read the book, any books called Enigma? Have you seen the movie? Yeah. Okay, so there are various versions of it. Let me digress for a moment. During the Second World War, yes. He was a mathematician, not a computer scientist, because computers didn't exist yet by that time. So he had to decrypt the German codes. They found 1 or 2 code books, and the Germans had to sync. They have this special machine called an Enigma machine, which looks like a typewriter, but it has these settable cogs in the middle. And the code is really unbreakable, but then they had to sync by sending one plain text thingy in front, a piece of plain text to synchronize the machines and off-key. And Turing defined a mathematical model that helped him to build a real physical machine. Yes, hardware, not a computer, just a machine in terms of gears. Think Lego technique. with gears and stuff that can churn quickly through all the possibilities, because the code was changed every day. So you had one day to crack the code. Yeah? And in order to do this, Turing had to know what it means to compute. Yes, you all grew up in an era where computation is just a given. There are things called computers and they compute. But there are two issues at hand here. The first is not every problem has a solution. There are some problems that you cannot program. Go Google the domino match problem. Yes. This is an example of a problem that is not computable. To be computable, you need to have an answer. Yes. So this thing may churn and churn and churn, and you never know whether there might be an answer in the future yet, or whether the answer is no. Okay? So the infinity is the bummer over here, because computers have finite memory, therefore they cannot solve infinitely large problems. Okay? So the model, the mathematical model devised by Turing is called, a Turing machine. And basically it captures in an abstract way what is computation. And today we know that if there is a problem that I can solve, if you give me a problem and I don't know whether I can write a computer program to do this, I can simply say, well, can I write down a Turing machine for this problem? A Turing machine that will solve this problem? And if the answer is yes, then the problem is computable, it's solvable. If you cannot write down a Turing machine for it, then the problem is not solvable. Something like the domino match problem. Then you also have the thing. So problems are either solvable or not. They're either computable or not. Yes? So if you apply at Amazon or Google, one of the things they will throw you with is, how would you write a program to solve this problem? And you will have egg on your face if you don't know about this thing, that some problems are not solvable, because they will give you an unsolvable problem and see if you'll try to write a program to do this. Okay? Then you don't get the job. So we know about solvable and unsolvable problems. In the class of solvable problems, what you will start doing in chapter 4 is you'll say, how quickly can I solve a solvable problem? Okay? So some problems are very quick to solve, others will take an inordinately long time to solve. For example, may I repeat that example that Prof. Geldenhuys and I are working on at the moment? The possibility space is equal to the number of atoms in the universe. So clearly, we have to be very clever at how we want to tackle this problem. Okay? I know you should really write things and run it on a computer. Take some of the exponential problems that you have in the front of the book. Just put it on the computer and increase n all the time, just to see how this grows. You'll be surprised at how quickly things can get slow. Yes? Our problem, incidentally, has to do with a specific type of graph where we want to find the longest path in the graph that covers all the nodes. And that sounds reasonable, but this is a known NP complete problem. And waving it's not polynomial, so we know it's one of the most difficult problems to solve in terms of time. So we are looking at whether we can find clever ways of selecting our choices so that we get to the answer quicker. Right. Ooh, we are a little dog, I know. Computer sounds just so nice, and now they want me to talk about stuff. Okay. Let's get there. I have a name, I have a current cash balance, then, what is that? Cash balance? Oh, the number of stocks held. This poor guy just had 5 stocks. No, let me not talk politics. Okay. Stupid politics caused the death of Alan Turing, right? Let me go read up on it. It's ridiculous. Okay, 5 stocks. And then for each stock, giving the number of shares and a code for each share. What is the share? The ticker symbol. So that's my input. So therefore, if I want to look at stock accounts, I must be able to read that information from that file. Okay? Now, what we need to do is we want to make an object, right? This is what this chapter is all about. So how do I write my object called stock account? Okay? The very first thing you do, because that makes you feel good, is you make a public class stock account. Okay, got it, right. Now, the second thing you need to do is you have to know what are the instance variables. Okay? And in this case, we just identified it. There will be a name, there will be a cash value, there will be a number of shares, yes, that 5, the number of, and then there will be an array of shares with the corresponding ticker symbol. Yes, okay. So that is fairly straightforward. However, what you will have to decide in your project now, my pointer vergeet. What you will have to decide in your project is which ones will be final and which not. Yes? So in this case, it seems that the name, if I have a stock account, clearly it's not South Africa, so the silly women don't change their surnames when they get married, so the name never changed, so let's make it final. Incidentally, you now see that in South Africa, you have the program. If you use this in South Africa, and a woman were to get married and change her name, you would have to delete her account and set up a new account. Silly, 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 don't change your names. Okay. The other things all change. The cash that our client has, the number of shares that he has, the specific kind of shares. Maybe I'll wake up and I say, oh, I want to buy IBM shares now. The exchange rate is looking better this morning, so it might be a good thing. Okay, right? So, for example, in your project, what would possible objects be in your project? Forget about the input parsing, forget about the GUI, you have to make objects. Give me examples of possible objects in the project. En daar's 'n doodse stilte. Ja. A car! That might be an object, yes. What else? The board, which I call the parking area. Yes, so the board, which is the parking area, might be an object. Would there be any other objects?
There are blocks.
But are they not the cars?
No, but the one car. Okay, yeah, sorry.
But you're almost there. So I have an object for the parking space, the parking area. And then I have cars, but what am I missing? The parking places? Maybe think about this. I'm not saying this is correct. I'm just giving options. Maybe you want to know that there are specific parking spaces, so you want to identify possible parking spaces as well. Which are the cells in the grid? Maybe, maybe not. How do I decide if I think of a possible object? How do I know it's a good object to have? What is an object? No, what is it? I'm calling it object. You know, I mean data types, right? What is a data type? Ms. January, what is the definition of a data type? Well, you see, it's in the test. No? Definition of a data type? Yeah.
It's a set of values and operations which can be.
Good. So if I think of an object, I'm thinking about the values. Yes? So if I have the parking space, no, take the other one first. Suppose I have all these blocks. I can imagine that they might have values, right? Because they have a width, and they have a height, and they have a position. So that's cool. That sounds like a really good object to have. The next thing I do.
They also have color.
Oh, and they have colors. Yes, because there's one that's red. And, yeah. And the other thing that I have to think about is operations on those values. So what operations might I have on a car? On a block?
Well, you could move whichever direction.
Move up, move down, move left, move right. Yes? Incidentally, would you like to turn the blocks? I think the generalized solution would actually allow you to turn blocks, but that is very difficult to implement in terms of the solution, so don't implement it. Please don't. But in general, the most general concept in this problem might be nice if you could turn as well. Okay? But in this case, it's not quite clear. Also, your parking space doesn't look like a real parking area with designated things and open space where you could have made a turn. Right? So you don't have this idea of the path the road where I drive and then I pull into. So it's not that general. It's a restricted form. But incidentally, if you're interested, you might think about turning. Don't implement it though. I guess you wouldn't have time. Okay, so the thing is, you look at the problem. You're asking yourself, what are the things, the data values? Yes, and what are the operations? So in the beginning, I look at the stock account. And I say, what variables do I need for that stock account? And then I ask myself, can this thing change? Yes, and that decides whether I make it final or not. By default, please, when you program, always make it private. The instance variables, make it private. You can make it public, it will still work, but it's a dangerous style to follow because then the whole world and their friends and their Pokemon can change anything in your model. Okay? So the whole idea about having these private data modules is that you protect your data so that you can find where things go wrong. If there's a bug, you can identify 3 or 4 or 5 lines of code that might have caused this bug, instead of 5 million and their test clients. Okay. Right. Now, so the next thing you look at, once you have your data type defined, and once you have the data values, the instance variables, then you think about what the possible operations are. You simply write down the API. And in the next section, in 3.3, we'll have a look, and we'll have a look at very many examples on how many instance methods should I put into a model. Yes. And the idea is that you don't, if you have like a gazillion instance methods for one data type, then your data type is very broad, and that is not a good thing, okay, which we will look at in section 3.3. Okay? So your number of operations must not be too many. Okay, so look at, then once you have the instance variables, you write down your API, and now you start programming, normally in Java, each of those. And the first instance method that you implement is the constructor. What does a constructor do?
Creates an object. An instance, it instantiates the object.
Yes. And how do I write it? What does the Java code look like to do that?
It's the access modifier public and the interesting name of the class with parameters or default constructor output.
And I get the parameters into the constructor, and I simply assign those values to my private instance variables. So as far as the Java code is concerned, the inside of the constructor method simply contains assignments. Yes? And those assignments take the parameters and assign them to the instance variables. Because, as you so rightly said, I have to instantiate the object. Now, what does this mean in terms of memory? Yes. In my client code, I declared a variable, I get a memory space. I knew the new gives me a space in memory and a reference to that space. Yes. But there are no values in there yet. So then the constructor fills in those values in memory. That's all the constructor does. It should do. The constructor shouldn't do anything more. It constructs the values in memory. Okay? Right. And then I can look at the other operations. This is just a print. There's nothing strange there. Print report, what does it do? I can't even see what it does. Where's my... Oops, there's something strange. What is this stop quote thing? Stop quote dot price. Is stop quote part of our API? No, it's not. So what is, if you just look at the Java and I ask you, is that a library? Is that a different object? Is that just a method somewhere in a hidden method somewhere that I can see only inside? What is stop quote? What would you guess? Look at the Java, look at the syntax.
Library.
He's says it's a library? Who agrees? Who disagrees? Oei, jy sien die res van julle sit op die draad. Miss Daly. Look at the Java. The Java has, by convention, a word starting with a capital letter, followed by a full stop, followed by a word with starting in undercase, and it's sending its a value. So you might say it's looking like math.random, and in this case it would be a library, and there's a library called stock quote. But why would they have a library for stock quote? That's somewhat strange, yes? Because we know that if it was a variable of type stock account, then I call it differently. I say variable name, which is an undercase, yes, dot print report, yes. So this indeed, I have to agree with you, on the face of it, looks like a library call. Can you see how I get there? I'm not sure if I'm right. You have to read the book. Okay. Good. So what I want to do next is look at a few intricacies of creating the code. How do I write the code for my new data type? Yes, point out the things which might turn out to be a bit difficult. So I thought I wanted to, you see, dis dan nou net maar julle projek. Okay, but let's do the exercises. If you humor me, let's work through the exercises. So this is a typical test question. I'm giving you a data type implementation for rectangles. Okay? And the rectangles, each rectangle has a coordinate of its center point. In your project, the rectangles that I ask you to create are identified by the left bottom corner. Yes, not the center. Okay, so it's slightly different. So there's a class rectangle. The API gives me the area, the perimeter. Does this rectangle intersect another one? Oh my, look at your project. The answer is in the book. Yes? Do we have any intersections? Is one rectangle contained in another one? And I can draw the rectangle. Okay, so how, this is the API therefore, yes, those instance methods. How do I declare a rectangle? In other words, what are my instance variables that I would need to identify a rectangle? Well, I would have to have a width and a height. There's a semicolon missing. Two of them. Okay. Private final double X, semicolon. Note that those are all finals. Because once I have an object that is a rectangle, its width doesn't change, its height doesn't change. In the project, its position might change. Yes? But here we want it fixed. So XY is all final. Then the constructor, well, what I would want in my constructor to create a rectangle is I want to send those parameters over that will allow me to initialize the instance variables and offski. There we go. Okay, nothing strange about the constructive. To get an instance method like area, it's, oh, interesting. Why are there no parameters for area? Why does my client code not need to send parameters?
The variables width and height are saved.
So once I have an object, it's set. But doesn't my code over here, does it not need to know which object I'm talking about? Why am I not sending the variable which identifies the object?
When you call that code, you give it a name as the...
Exactly. You would say, for example, r.area. Yes. It returns a double. Why don't I have a static between public and double? Yes.
Instance method.
Yes, thank you very much. Okay, perimeter, same thing. Now we get to this somewhat awkward syntax that you have when you use objects. It's a bit like complex plus. Remember with the complex clause, we had the plus and the times, and it was so much easier to write the plus or the times, but we couldn't. We had to write out the name of the instance method. So I'm sending over a rectangle B. How does, but how can I only send over one rectangle when I want to find the intersection of two rectangles? Correct, 100%. Because I'm saying A dot intersects B. So the object already has the one I'm talking about. Yes, and now I'm sending it another object to see if those two objects are intersecting. Okay. And the code is not there. Yes, how would you implement intersect? Because you're going to need it for your project, so let's leave it there. It's got nothing to do with object orientation, right? It's simply calculations of coordinates within the Cartesian plane. Yes, you're with me. You're looking at the width and the height and the coordinates. And right. Incidentally, you do know that there are other planes as well, yes? Do you know about hyperbolic space? Please read up on hyperbolic space. That's very interesting. People lie to you your whole life. They start out with the Easter Bunny, and from there it just gets worse. You learn in high school that two parallel lines never intersect, but they assume the world is flat. The world is not flat. You're not always working with Euclidean geometry. Yes, if you work on a sphere, for example, things look quite different. So read up on hyperbolic geometry. Very interesting. Parallel lines can intersect in hyperbolic geometry. And so on and so forth. Where is this interesting? This gets interesting, for example, in graphical user interface layout on small devices. It's sometimes much easier to do layouts on a sphere rather than on a flat plane. Imagine you have to draw a graph of all the possible IP addresses and all the possible network connections all over the world. How are you going to draw it on a flat screen? You are going to build a sphere. Yes, because that's just easier to model and much more realistic anyway. Because you know that our flat maps in an atlas is anyway, it's wrong. It's a projection, it's not of a 3D thing to a 2D space. And so what happens in graphical user interfaces, suppose, yeah, Western alphabet is so easy. It's got 26 characters, so you can draw a nice little keyboard. Suppose I want to make a mobile phone with a keyboard which contains the alphabet when I speak Mandarin. So your minimum number of characters is 5,000. That's the usable subset that most people know is about 5,000 characters in Mandarin. How am I going to put it in my user interface? So what people do is they make it round, and then as you type, you do projections of what the next possible characters may be according to the grammar rules, and then you display the possibilities in a circle around the current character so that you can select that. And then this whole thing moves like that. Okay? Great. How the hell did I get to Mandarin? But okay, a very useful extra subject. I'm just saying. Okay. This is a good one because I have things like this in the test. Yeah, assessment. Public class charge, private double RX RYQ. I'm very tired of charges, but here we are. What is wrong? What's wrong? What's wrong? Is it clear? Ik heb graag niet verstaan. Ik ben nog heel begrijpen hoe het staat.
Let the public class charge done multiple private variable Rx and Ry. But any constructor needs to be it.
Nice. Did you catch that? Yes. Did everybody catch that? Rx and Ry and Q are redeclared in the constructor. That is incorrect. You're making local variables over here, whereas I already have my private instance variables. Okay? So what you should do to prepare for the test is work through these kind of exercises, see what looks wrong. You have to carefully take note of the standard syntax of the examples in the book so that you can immediately, if it differs, if I give you an example that's wrong, you can immediately say, oh, I can see because it's different from all the template of all the other examples I saw in the book. Okay? Ach nee, ek gaan nie doen nie. Here we are, rational. You have had complex, yes. You won't have time to finish this. We have had complex as an example. So here you have rational. This is student see, student do. I wanted to see, the idiom is monkey say, monkey do, but you are not monkey say. Student say, see, student do. Take class complex, look at it. Write out the code by hand, pen and paper, to do the same for rational numbers. Yes, your plus and your times and things will look a bit different. And you will have two, just as with complex, you will have two numbers. With complex, it was the real part and the imaginary part. In this case, you have the numerator and the denominator. Yes. Write those things, then type it into Java, compile, and run a few tests so that you can get used to implementing these things. Okay, and so on and so forth. And what we'll do then on Monday is we're going to start assigning. Okay, great. Enjoy your weekend. I'll see you on